Our next topic is rational expressions. Notice that we have a polynomial over a polynomial, so we end up with variables in the denominator. One of our main focuses for working with rational expressions is going to be talking about the domain restrictions. Whenever you have a variable in the denominator, there's a potential that you are dividing by 0. So we're going to be looking at what could make the denominator 0 and making sure that we identify that as a value that we can't use as part of our domain. As a reminder, domain is input into a function. So in this case, our domain is anything that we can substitute in for x that will give us a real number, meaning anything that won't make us divide by 0. Our essential question links back to what I was just talking about, focusing on the domain for this lesson. So let's take a look at simplifying our first example, and then we'll talk about our domain restrictions. Hopefully in the numerator you recognize we have a difference of squares, so we're going to factor that into conjugates. In the denominator I have a 5 and an x, but the x is negative. So I'm going to factor out a negative so that I can maybe get that to match one of the two factors that I have in the numerator. I'm also going to flip it around so that it's in the same order. So I'm factoring a negative away from the x and away from the 5. So my positive 5 becomes negative. Now I have a common factor in the numerator and the denominator, so I can cancel those out. That negative that is left in the denominator will move up in front of that x plus 5 that I have left. You can leave it in factored form, or if you prefer, you can distribute that negative sign through. Next, let's talk about our domain restrictions. Anything that makes the denominator 0 is a value that we cannot use for x. In this case, when I solve for x, I'm going to add x to both sides because my x was negative. So my domain restriction is x cannot equal 5. Any other value we can input into this function, including the simplified form. I still can't put 5 in my simplified version because it would have made my unsimplified version undefined. Part B, we have a note of caution in that right-hand column. I see students do this all the time. They want to cancel common factors when the expressions aren't in factored form. We have to factor before we cancel. In the numerator, we have t-chart. What multiplies to 12 and adds to a negative 7, that would be negative 3 and negative 4. In the denominator, we have t-chart again. What multiplies to negative 18 and adds to a positive 3, that would be a positive 6 and a negative 3. We have common factors now that they're in factored form, so those x minus 3's will cancel, leaving me with x minus 4 over x plus 6 for the simplified version. In order to find the domain restrictions, it's helpful to use the factored form of the expression instead of the original form. So I'm going to talk about where x plus 6 times x minus 3 cannot equal 0, because we have the zero product property here. So either x plus 6 cannot equal 0, so x cannot equal negative 6, or x minus 3 cannot equal 0, so x cannot equal 3. So our domain is all real numbers except positive 3 and negative 6. One more example, this time in the numerator we have that GCF of x, leaving me with x squared minus 4. In the denominator we have t-chart again. What multiplies to negative 2 and adds to positive 1, that would be a positive 2 and a negative 1. We don't have any common factors that will cancel. However, in the numerator, we have a difference of squares again. That x squared minus 4 we can factor into conjugates. And now we get our x plus 2's to cancel. Leaving us with a simplified form. Make sure you leave this answer factored for your final answer. And then we can talk about our domain restrictions. Again, looking at the factored form of the denominator, where we have quantity x plus 2 times quantity x minus 1 cannot equal 0. So we set each piece not equal to 0 and solve. Our domain restriction x cannot equal negative 2. X minus 1 cannot equal 0, so x cannot equal 1 are our two domain restrictions.